Hey guys, welcome to another circuits video. So today I wanted to talk about uh, how to find the total resistance when the resistors are connected in parallel. Parallel. Alright, so if I have this circuit right here, let me draw that circuit. Okay, so right off the bat, what do you observe? You observe that since these two endpoints are the same, the potential difference is going to remain the same, right? There is no change of potential difference because we can measure potential difference at only one spot. Can't be. Uh, but what is going to change though is the current. I mean, it's not going to change. It's just going to split up into three different currents. All right. So when now the current, like the charge is coming here, right? And some of the charge goes here, some of the charge goes here, and some of the charge goes here. All right. So let's call this sum of the charge. Let's call the charge going up to this R1 resistor. Let's label our resistors. This is R1, R2, and this is our R3, right? So let's call the current going up to resistor 1 I1. Let's call this I2, and let's call this I3. Hopefully you understood that because I rushed through it kind of. And we have measured this total current with the ammeter. So let's call this total current I. Okay, so we know that the total current passing through the circuit is going to be equal to the sum of the currents going through all three resistors. So I equal to I1 plus I2 plus I3. All right. And now if we apply Ohm's law, what does Ohm's law say? Ohm's law says that V equal to IR, right? V equal to IR. So how can we turn this equation into something which equals I? We can do something like okay, no, not like that. We can do something like V by R equal to I. All right, I just got this down here in the denominator. So I is equal to V by R. Now what can we infer from this? We can plug this value in here. So what happens now? Let's pick a different color. I is equal to V by R. The total current is equal to the total potential difference, the potential difference upon the total resistance. This is going to be equal to V by R1. And why is the potential difference constant? Because there's only one place where we can measure the potential difference, because all the endpoints are same, right? And you cannot just, I mean, even if you measure it here, it's going to be the same if you think about it, because these 2 points are the extension of these 2 points. So technically the potential difference remains the same throughout the parallel circuit, right? So we can replace this by R1 because we are talking about the current moving through this first resistor. Now we can replace I2 by V by R2, right? And we can replace this I3 by V by R3. Hopefully you understand what we are doing. We are just plugging in the values of these resistors to hopefully give us the current which we are getting. All right, so what is common here? V is common here, so we can cut the V out. And what do we get as our final equation? As our final equation, we get that 1 by R, the total resistance, 1 by the total resistance is equal to 1 by the sum, like the 1 by R1 plus 1 by R2 plus 1 by R3. And this works for any number of resistors. By the way, you are not limited to 3. You can do this for as many resistors as you want. But if resistors are connected in parallel, you to find the total resistance, you have to add up the reciprocals of all the resistances, right? Reciprocal means that you just convert the numerator to the denominator. Just a little refresh. I know you knew it. I know you knew the answer. No need to hate in the comments. But uh, 1 by the total resistance is equal to sum of 1 by all the resistances. Okay, remember this equation. And if you want to prove this in a 5-mark question, you just have to make this. You'll have to write the principles. Okay, I'm not writing everything, but if you write everything in words, then use the symbols V, R, I, and then solve everything. Okay, and always remember, never confuse series and parallel. That is a horrible mistake to do. Never confuse series and parallel equations. So whenever resistors are connected in parallel, the total resistance is given by this equation. Alright, so hopefully that was clear to you, and I will see you in the next video. So guys, that will be the end of this video. If you like this channel, don't forget to subscribe and drop your doubts, if any, in the comment section down below so I can answer them as soon as possible. And until next time, I will see you guys later. Peace out.